Hello friends. So till now we have discussed a basic notion of a register and one of the classification type, which was depending upon the input and the output data. In this session we are going to discuss about another classification type, which is classification based on its applications of a register. So a register can be either used as a shift register or it can be used as a storage register. Let's see what we can do while using it as a shift register or as a storage register. So when I say I am using it as a shift register, that means I am using the register with moving the bits or shifting the bits, like we just saw in the previous video. In case you have not viewed how we shift various bits, you can please view the previous videos. So what happens and how the shift happens is we can either shift the bits. Let's say I am shifting the bits on left side, then it is called as a left shift operation. And if I shift the bits, say on right hand side, one bit at a time, then it is called a right shift. So you see, when I shift the bits on left hand side, the entire number which was represented as 0010 has now become 0100, right? What I've done is I've just shifted these bits one bit at a time. So now if I would just map both of these for your clarity, it would be like this 0 has gone over here, which is now out of bound. This 0 has been shifted over here, this 1 has been shifted over here, and this 0 has been shifted over here. And since I had to put one of the bit over here, so I've just taken one extra bit out of nowhere, right? So that is a 0. When we take an extra bit out of nowhere, we take it as 0. So this is a simple left shift operation, and this is an example of a shift register basically. And what we just saw till now was we saw various types of shift registers, but if I would categorize this specific one, it would come in the category of what? Come in the category of serial input but parallel output, as I am viewing the outputs at this particular stage. Whereas the basic shift register concept that we discussed till now offered the output at a single one exit point, which was located at the extreme right end, right? So this one basically offers the output to be viewed at all the bits. So that means this is a classic case of serial and parallel out, right? So if we just go to its application point of view right now, we'll go into the details of how various serial in, serial out and the other registers work in the following videos. But for now, if I say this is a left shift operator, and what does a left shift operator signify in arithmetics? It is multiplication by 2. How does it happen? If I represent this binary number in decimal, it would become 2, right? 2 in decimal. And if I represent this number which I have obtained after left shift operation, this is 4 in decimal. So essentially we are basically multiplying this decimal number with 2 when I'm saying I'm performing one left shift operation. Now, in case you don't know how to convert a binary number into a decimal number, you just need to know that the entire number, let's say I want to convert this binary number into a decimal number, the entire number is multiplied with the data bit weights. And the weights are nothing but they are the powers of the radix in this order. The radix over here is which is representing the number system. So since it is binary, it is 2, and I'll be multiplying it with the powers in increasing order from right to left, which is 2 to power 0, 2 to power 1, so on. So the number will be 0 into 2 to power 3 plus 0 into 2 to power 2 plus 1 into 2 to power 1 plus 0 into 2 to power 0, which is nothing but 1 into 2 to power 1, which is equals to 2. So similarly you can do it for this one, which will yield you 4 as the output. So you see that performing one left shift operation for all the bits yields the multiplication of the number with 2, Right. Now let's see what happens when we perform a right shift operation. So essentially for this, I'll be shifting all the data bits by one position on the right hand side, right? So this will come this side, this will come this side, this will come this side, and I'll have to take one extra 0 from left hand side, so I'll be taking it as 0. And so now this number has become nothing but 4, and this has its equivalent as 8, so we come to know that this is nothing but division by 2, right? So right shift operation is equivalent to dividing the number by 2. Now for storage registers, we have already discussed in our first video that they are used as for storing a multi-bit data, because we know that one flip-flop can store only one bit of data. So multiple flip-flops are used as a combination, which is termed as a register. So a register is nothing but a combination of various flip-flops. So it is used to store the data, and the various examples which exist are memory data register or memory buffer register, right? So this was all for this session. In the next sessions, we'll be dealing with all the various types of registers in various details with the complete their structure diagrams and their definitions, etc., and their working. Please view the next videos and stay tuned in the sequence. In case you have any doubts, you can always post them as comments. Thank you. In case you like the video, please like it. Thank you and stay tuned.